We are continuing with cone in this video also. Now he's saying that the height of a cone is 40 centimeters. So we have a cone like this, and the height of this cone is 40 centimeters. So we can say that capital H is 40 centimeters. A small cone is cut off at the top by a plane parallel to its base. So there is a small cone which is cut off from the top and the base is parallel to the given cone, right? So let the radius of the big cone be r and the radius of the small cone be small r, and the height of this cone be small h, right? If its volume be 1/64th of the volume of the given cone. Now the volume of this small cone is 1/64th of the volume of the given cone. At what height above the base is this section cut? So we have to find the height at which this section, this cone is cut from the original cone, right? So what we will do is, h is given 40, right? This is my 40, and volume of this cone is 1/64th of the volume of the actual cone. So see what I will do. I have so many unknown things here. So I will name this as A, this as B, this as C, this as, let this be D, and this part be E, right? So what I will do is, I will try to make, this is 90 degree, it's a right circular cone, so this is also 90 degree. If you look at the triangles AED and ACB, they are two similar triangles, right? Why? Because this angle is 90 in both the triangles and this angle is common in both the triangles. So can we say that these two triangles are similar? Yes. So we will write. So how will it help us? We will understand that. So we will take triangle, or we can simply write, you don't need to prove that, you can simply write triangle AED, but you can show it in the figure, is similar to triangle ACB, right? These namings have to be in the perfect order, because A of this triangle, A of this triangle, E of the small triangle, and C of the big triangle, and then D and B, because both are 90 degrees. D and B, they should be placed in the proper order. So they are similar, right? So by AA axiom. So now when they are similar, we can say that their corresponding sides are proportional. That's what actually we require. So we can say that AE upon AC is equal to ED upon CB is equal to AD upon AB. Okay. Now let's see. AE and AC we don't require. Let's go to ED. We'll prove that ED upon CB is equal to AD upon AB. What is my ED? My ED is small r. And what is my BC? It is big R. Is equal to, what is my AD? It is small h. And what is my AB? It is big H. Right? So let me keep it as it is. Now I will use this situation which is given in the question. Volume of this cone, small cone, that is 1/3 pi r square h is equal to 1/64th volume of the big cone, right? So 1/3 and 1/3 will go. Okay, 1/3 pi also. Pi and pi will also go. So I'm left with r square h is equal to 1/64 into r square this edge I have 40, right? So what I can do now is, this will be 8 5s are 8 8s are. If I see the situation here, if I bring this r square down here, what will I get? R square upon capital R square is equal to, I will have 5 here. I'm bringing this down and bringing it here down, 8h, right? This is the value. If you cross multiply, you're going to get the same thing. 8r square h, 5r square, right? Now, this is what I have with me. Fine. Now, how will I use this? So, I will use this as value of this, h upon h whole square is equal to 5 upon 8h. So, this will become h cube, h square upon 40 h. I have 40. So, 40 into 40 is equal to 5 upon 8h. So, if I cross multiply, I am getting 8h cube is equal to 4 4s are 16, 1600 into 5, right? So, further 8 2s are, so my h cube is equal to 1000. Does it mean that my h is equal to 10? Is it centimeters? Yes, centimeters. Now I got this small h as centimeters. Now he wants me to find at what height above the base is the section cut. Does that mean I have to find h minus h? Yes. So my capital H is 40 minus 10. So at 30 centimeters, this base, this cone must have been cut. Now, another question. In this question, I am given a hollow metallic cylindrical tube, right? A hollow metallic cylindrical tube is given. So this is like this. Fine. It has an internal radius 3 centimeter. So internal radius is 3 centimeters. Fine. And height is 21 centimeters, which will remain same whether you are looking at the height internally or externally. Height will remain same. The thickness of the metal is 0.5. So what is given? Thickness of the metal. Thickness is 0.5 centimeters. So how will I use this thickness? In calculating the external radius. How do I calculate the external radius? Internal radius plus thickness, that is 3 plus 0.5, that is 3.5 centimeters. Fine. I got the internal radius, I got the external radius. I can calculate the volume of the metal used to make this tube, right? Hollow metallic tube. How? External volume minus internal volume. I know how to calculate the volume of the cylindrical material. That is calculated as external volume minus internal volume, right? We have to find the radius of the, okay. Now this is melted and is cast into a right circular cone. So we have melted this and it has been casted into a right circular cone where height and the radius are at right angles. Cone of height 7 centimeter. Height of this cone is 7 centimeter and he wants us to calculate the radius of this cone which we have made by melting this cylindrical tube. So what is remaining same? Volume of this will be equal to the volume of this, right? Now volume of this we know is external volume minus internal volume, which is equal to volume of cone. So external volume is pi capital R square h minus pi small r square h, which is equal to 1 by 3 pi. Let's keep the radius here. Let's not name it r because we have already named this r here. Let's name it p here. So p square into h. In place of h we can write 7 because the height of this cone is given. Now we can take pi and h common, and inside we have r square minus small r square equal to 1 by 3 pi p square into 7. P is the radius of the newly formed cone. Now pi and pi will go. Height of this is 21 centimeters, and here r square is 3.5. So 3.5 whole square minus r is 3 whole square is equal to 7p square by 3, right? So you can even cut this 7 3s are. Now cross multiply, you will get 9 into a square minus b square is 3.5 plus 3 into 3.5 minus 3, and this side you are left with only p square. Now you have to calculate this p square. Now see, this is 9 into 6.5 into 0.5, right, equals to p square. Now this will again become 9 into 65 into 5 divided by 100 equals to p square, right? 9 and 100 you can keep separate as 9 3 by 10 whole square, and here you have 13 into 5 is 65 into 1 more 5 equal to p square, right? Further what you can do is you can write 3 by 10 whole square into 5 whole square into 13 equal to p square. Now this square and these two will go and root will remain with 13. So you will have 3 into 5 upon 10 root 13 equal to p, which is the radius here. Now 5 2s are, so you are left with 3 root 13 upon 2 equal to p. Now root 13, value of root 13 is 10.80. So you have 3 into 10.80 upon 2 equal to p. So that makes it, sorry. Here your root 13 is 3.60. 3 3s are 9. Yes. So 3.60 into 3 upon 2 you have, which is equal to p. So this will become 10.80 upon 2, which is your p, or your p can be written as 5.4 centimeters. He has asked you to write it. He has asked you to write it correct to 1 decimal place.